Happy fall, y'all! Or whenever you're watching this video, it just happens to be fall while I'm recording it. So happy fall, y'all! We're doing section 3.1 about lines and angles. So this is a new unit. We're going to be doing a lot of stuff with angles and lines in this unit, um, as well as many other things that have to do with that. But this is the first section, so this is kind of the foundation of a lot of the things we're going to be working on this unit. So our two goals, we have two goals today. First one is to identify relationships between figures in space. And second one specifically, so that was our first one. Second one was more specifically to identify angles formed by two lines and a transversal, something you've been introduced to in the past. All right, so let's jump right in. First of all, a key concept for what we're going to be talking about right now happens to be three different vocab words: parallel lines, skew lines, and parallel planes. And they're all similar, but all slightly different. So take note of these three things. First one is parallel lines. Something you see all over the place, but it's also something that you've known for years. But parallel lines are coplanar, meaning they're in the same plane, and they're lines that do not intersect. Okay. This little symbol right here, these two lines next to each other, refer to as parallel. So we could write parallel lines like this or like this. It's saying that line AE is parallel to line BF. So that's referring to this line right here and this line right here on the diagram. And line AD is parallel to line BC. That's right here and right here. And one thing that you'll see, you can kind of see it on the diagram, but anytime there's the same amount of arrows on the lines going in the same direction, that means that they're parallel. So if this one has one line on each, they're parallel to each other. If these two would have two lines on each, that means they're parallel to each other. It's a similar labeling as we do with like congruent lines and angles. All right, second vocab term, skew lines are essentially parallel lines, but they're not in the same plane. So it's lines that are non-coplanar, but they're not parallel and they don't intersect. So an example could be right here, AB and CG. So let's take AB here and CG. Hopefully you can visualize that a little three-dimensionally. So I'm going to draw that a little bit different here. But if you look at these two lines, they will never cross, but they're also not parallel because they're not in the same plane. And then parallel planes are planes that do not intersect. So you can see in the diagram the top and the bottom. So those are parallel planes for you. So let's look at right here, just some labeling. It says red arrows. In this case, red arrows are used in diagrams to indicate the lines are parallel. But like I said before, it could just be the same, even if it's not red, it could be just the same number of arrows going in the same direction. So in this case, line L is parallel to line N. So let's look at a couple examples over to the right. It says name all names all planes parallel to plane ADH. So plane ADH is actually the one in the very front. So anything that's parallel to that, meaning it would never cross, the only one there would be plane, the one on the back, which we could say is BCG. And if you used K in there instead, that would work as well because they're all on that plane. Number two, name all segments that intersect at segment AT. Well, if it has an A or a T in it, it's going to be intersecting with that. So you could say segment TH, you could say AB, you could say AC. These are all segments. TK, you could say AD. That's all of them. Number three, name all segments that are parallel to segment AT. So we know that segment DH is parallel because it's in the same plane. And we know that segment BK is parallel because it's in the same plane. It's never going to cross. You can use, basically by the transitive property, you can find the fact that CG would be parallel, but if we're going based on the definition right now, we're not going to say that. Number four, name all segments that are skew to segment CG. So CG is going to be not in the same plane, but also not parallel. So an example of that would be like TH. They would never cross, but they're not in the same plane. You could say TK. You could say AD or AB. Technically, you could say AT as well, but AT, if you drew a plane through them, they would be parallel. So what's the difference between parallel lines and skew lines? Well, it depends on whether it's in the same plane or not. So that's the big thing there. All right. Now, what is a transversal? A transversal is any line or segment that cuts through two or more, let's say two plus, two or more other lines or segments. And so that's really broad, but that's because we usually think of transversal going through parallel lines, but it doesn't have to go through parallel lines. So let's talk about some different types of angles that are formed when you have a transversal. So here's an example over to the right, this picture. This line T is a transversal because it's cutting through line L and line M. So these are all defined in your notes, but alternate and interior angles, something you've learned in the past, are angles are non-adjacent interior angles, so not next to each other, but also still in the interior of two lines that lie on opposite sides of the transversal. So examples would be 3 and 5. Sorry. So an example would be line 3 or angles 3 and 5 because they're on alternate sides of the transversal, but they're both on the interior of our two lines. Same thing with 4 and 6. Those angles are considered alternate interior angles. Next one, same side interior angle. So they're still in the interior of two sides, but now they're on the same side of the transversal. So examples here would be 3 and 6 or 4 and 5. Those are both examples of same side interior angles. They're labeled pretty counterintuitively based on the name and based on the location. So this next one is called corresponding angles. Corresponding angles are angles that lie on the same side of the transversal and in corresponding positions. Essentially, they go together. So if you think about the two intersections, so we have one intersection at the bottom here, one intersection at the top. You're looking for angles that are in the same spot. So that's why 6 and 2, angles 6 and 2 are corresponding because they're in the same spot. They're in the top right. Angles 1 and 5, they're in the top left. So they're corresponding. They go in the same spots. And finally, alternate exterior angles. Alternate exterior angles are non-adjacent exterior angles that lie on opposite sides of the transversal. So alternate, meaning they're on the opposite sides of the transversal, and then they're on the exterior of the two lines. So that's why angles 2 and 8 would be considered alternate exterior angles. And then like angles 1 and 7 would be the other pair that we have on here that would be alternate exterior angles. Okay, as we get going in this unit, we're going to find some relationships about all those types of angle pairs when we have parallel lines, like if line L and M were parallel. For right now, we don't know that they're parallel, but we will get into that. So let's work through this example here. We have 3 different lines, and then we have one big transversal. This is the transversal because it's cutting through 3 different lines. And we have angles 1 through 12 labeled. It says identify each pair of angles by the special name. So I'm going to do that, but I would like you to try these on your own. There's 6 of them. but I'm going to probably be abbreviating just a little bit, okay? So, for instance, angles 1 and 8. 1 and 8. So they're on alternate sides of the transversal, but they're on the exterior of the two angles or intersections we have there. So those are going to be called alternate exterior angles. Again, there's some abbreviating there. Number 2, angles 2 and angle 6. 2 and 6. So we're in the same intersection here. They're both on the same side, but one of them's on the exterior, one's on the interior, but they're in the same spot. They're both in the top right. So that would be corresponding angles. All right, number 3, angle 7 and angle 10. So they're on alternate sides of the transversal, but they're on the interior of the two lines. So those would be alternate interior angles. All right, number 4, angles 8 and angle 9. So now we have angle 8 and angle 9. So those are on alternate sides, but those are on the interior as well. So angles 8 and 9 are also alternate interior angles. All right, we got 2 left. 8 and 12. So here we go, dealing with 8 again. Say we got 8 and 12. Those are in the same spot on those two intersections. So those are just corresponding angles. And then finally, 1 and 5. 1 and 5. I'll use blue here. 1 and 5, also top left. So those are also corresponding angles. So there we go. Some examples of finding those different types of angles there. All right, 2 different examples where we have examples with the transversal. One of them looks like a map. One of them just looks like a parallelogram. But in number 7 and 8, we want to state the transversal that forms the angle pair. So number 1, it says angles 1 and 3. So angle 1 and 3, because depending on how you look at it, you could have different transversals. 1 and 3, these are the lines that I think we're talking about. So the transversal would have to be line AH. Okay, that's the only line that they both have in common, and that would be something that a transversal would be. How about number 8, angles ATH, so that's this one right here, and angle MAT, so that's this whole thing right here. Now, for a transversal, you want to look for whatever line is in common, and really the only line that's in common is line AT. So we want to imagine the 2 lines we're focusing on here that are being cut by that transversal are right there, and I'm just extending them to see the visual. The line AT would have to be the transversal, even though it's not right down the middle of this diagram. That's the transversal. Okay, numbers 1 through 3, I kind of like them. They have to do with this is just a very rough sketch of a map of downtown of a city, and there's some different things at different intersections. And this is a realistic example if you want to dumb down a map and look for different landmarks that are in that city. And you'll see, like, when certain cities, they have parallel lines. They have some roads are not parallel, and then it makes things a lot more difficult. But there's still, you can see the relationships and angles. So number 1, it says name 2 pairs of locations that represent each type of angle. So like same side interior. Same side interior. You want to do the same side and on the interior of 2 lines. So let's just say we have the bank and the museum. Whoops. There's an M. Because they're on the same side, they're between in the interior of these 2 lines, and they're on the same side of this transversal. It says one other example. I'm going to let you come up with one other example. Let's try alternate interior angles. Alternate interior angles. So let's look at a different intersection. So how about, well, I'm going to look at the same intersection just because there's nothing listed at this angle or at this angle. So alternate interior angles, let's say the post office would go with the museum. They're on the inside of those same angles, but on alternate sides of the transversal. So post office and museum, and then you can come up with another pair. There is one more pair in there. And one other one, corresponding angles. So corresponding angles, we want to be in the same spot on the intersection. So for instance, if this is an intersection, this is an intersection, we would have the park going in the same spot as the high school, both in the bottom right of their respective intersections, with the transversal going right down like this. Park and the high school. So there's some additional examples dealing with transversals and angles formed by them. So why don't you finish off by, on your own, finding the errors, if there's any errors in here, and then answering the closing question, something that we've already actually talked about and answered, but it's a good review from the beginning, which takes us back to our beginning. And we talked about identifying relationships between figures in space. That would have to do with parallel lines, skew lines, perpendicular lines, we'll get into that, but planes as well. And then the second one was identify angles formed by two lines in a transversal. So the different angle types like alternate interior, alternate exterior, corresponding, and same side interior. So that's it for section 3.1.